Okay, good morning, 2.2 day two. Before we do anything, you should probably hit pause quick, see if you know what's going on from yesterday, and do these three limits, and then come back as soon as you get them done. And I'm going to continue to do them. So number one, the limit as x approaches infinity. Okay, remember yesterday x was getting super big. When I plug super big numbers in there, this is just going to infinity, which means it does not exist. Okay, I can see that that's a parabola, and I can see as I go big x's, big y's come out. Number two, as x goes to infinity, well, infinite limits, remember, they are horizontal asymptotes. That's what an infinite limit is it getting snug as a bug in a rug? And when I look at horizontal asymptotes, I horizontal asymptote hunt. So when I'm plugging in very large numbers, okay, this is really going to turn to, I don't care about the minus 3, minus 1. I'm really looking at the limit as x approaches infinity of, and then I can reduce this. This reduces to an end behavior model, like we said yesterday. And then when I plug this in here, I get 3 divided by infinity, or 3 divided by big, gets very small. So this limit is going to equal 0. In the end, what does that infinite limit mean? It means I have a horizontal asymptote at y equals 0, but we state the limit is 0. The last one down here, number 3, is as x goes to infinity, what do I get? I get the sine, and everybody gets wigged out by plugging in infinity, and I get it. It's an abstract topic. I get sine of infinity over infinity. Well, I got to think about this. The sine wave is a periodic function. I keep looping around the unit circle. So what I do know is this numerator is always unconditionally going to be poking out numbers between -1 and 1, because that's what the sine bounces between over infinity. Well, if I have -1, any number between -1 to 1 divided by infinity, okay, something divided by very big gets me very small. Now remember, this is not a horizontal, this is not a horizontal asymptote here, okay? That works with rational functions. This is not a horizontal asymptote because it oscillates. Okay, it oscillates above 1. However, the limit is approaching 0. Okay? Yesterday we looked as x got really big. What happened to the function? Today we're going to look a little bit different. Today we're going to look at as x approaches a. Now I think you have a different thing in there. I think you have a C in yours on your note packet, but so why don't I get you just to make sure you change as x approaches a, change your C to an A, and we want to look on both the right and left side of a, what is happening. So limits as x approaches a finite value. Okay, a is a finite value. Which direction is the graph going? Is it going up or down? So basically, if the value of the function f of x outgrow all bounds, what does that mean? That just means gets super big. Okay, gets super big. As x gets super big, what is happening? Okay. No, I said that wrong. The values of a function f of x outgrow all bounds as I approach from the left to the right as x approaches a finite number, we say. So as x approaches a finite number, it doesn't matter if it's from the right or from the left, okay? It'll dictate there. If I grow without bound, what that does is that describes the behavior. The limit, if my limit is infinity, it does not exist, remember. Limit does not exist, but it's used to describe behavior. It is used to describe vertical asymptotes, okay? This notation right here, if my graph is going to infinity, as I approach a particular finite value, describes vertical asymptotic behavior, okay? So, excuse me. Let me get rid of this. Let's revisit the one that we looked at yesterday, okay? Revisit f of x equals 1 over x, okay? Now, this is stuff you need to be able to see without a picture, and you need to remember these parent functions. This is the mother of all rational functions, okay? This is going to go, come in here, come in here, come here, like so. That is exactly what that little bugger looks like, and we're going to revisit this. Okay, note there's a vertical asymptote at 0. How do I know that? Well, I know that because the domain of this thing is all real numbers x except 0, because if I plug 0 in here, I get a number over 0. Number over 0 means vertical asymptote, okay? But we're never actually going to hit 0. We're going to get super, super close to it. Okay, so what is this going to tell me? Well, I got to see it. I got to see this without a picture. Okay, so as the limit as x approaches 0 from the left, now if I'm approaching 0 from the left, I'm really like negative 0.001. I'm really small, getting really close to 0 from the left side. Remember, here's 0. These are positive numbers. These are negative numbers. I can see my limit is going to negative infinity. Okay, how do I rationalize? How do I reason through this? Well, I reason through this by saying 1 divided by negative very small equals negative very big, because I got a positive divided by a negative. If I'm approaching from the right side, okay, well now I'm approaching from maybe the positive side, yeah, 0.001. I'm getting really close. I'm never quite getting to 0. I'm never quite getting there to make this undefined. But 1 divided by positive small equals positive big, okay? And if it's positive infinity, you do not need to write the plus on it. Just a plain old naked infinity, I'll call it, implies it's positive. But if it's negative, obviously you have to have the sign. You need to be able to see this behavior without a graph. It's a little abstract, but we need to see it. Did we graph that? Did Kruger graph that right? Yeah, there it is. See, it's going up there and it's going down there. Beautiful. Okay, on to the next example. I'm trying to get through these faster than I can so I can get these little buggers down. Formal definition, okay? The line x equals a, that's why I had you turn everything to a's up there from your c's. The line x equals a is a vertical asymptote of the graph of a function y equals f of x if either the limit as I approach that a value from the right side, as I get closer and closer to a from the right side, if I grow up or down without bound, or if I approach a from the left side, I grow or go down without bound. That is the definition of a vertical asymptote, okay? Do not forget left side minus, right side plus, okay? Directions for finding. Directions, what we're going to do is we are going to find the vertical asymptote of the graph of f of x and describe the behavior of f of x to the left and right of each vertical, asymptote. Now, I'm going to get rid of all this business here. And before we really get into here, there is some previous knowledge that you need to bring to the game here. You need to be able to look at some of these functions. Granted, and don't freak out when I'm saying you need to know this. You do need to know this, but you're going to get to it. But these are baby functions here, okay? You need to be able to look at this function right here, f of x. And you need to be able to tell me really quick, the domain is all real numbers x except negative 2. And I know it's all real numbers except negative 2 because negative 2 gives me a 0 denominator. And 0 denominator is issues with fractions, okay? So when I actually look at this, I can see there's no 0 over 0. When I plug that in, I actually get negative 2 over 0, and you know what that means? A number over 0 means vertical asymptote at x equals -2, okay? So that's some knowledge you need to bring to the game. You need to be able to get the domain of a function. The other knowledge you need to bring to the game here definitely is a horizontal asymptote, okay? Horizontal asymptote, we're going to use here, we're going to use the power thing, okay? And I can see my powers are equal. The coefficients are both 1, so I know the horizontal asymptote is going to be y equals 1. So what that means is, that means the limit, horizontal asymptote, that means the limit as x approaches positive or negative infinity of this function x over x plus 2, this limit is going to equal 1. This is by definition a horizontal asymptote, okay? But we can see that with the power thing, but that's in calculus, horizontal asymptotes, that's what it means here with the limit, okay? And I'm going to dump that off for a quick second. So what do we need to be able to do, okay? We need to be able to see all of these goodies. And like I said, this is a vertical asymptote because the denominator is 0, okay? Remember, number over 0, vertical asymptote. 0 over 0 is not a vertical asymptote. That equals a whole. Okay, we don't have that here. We have a vertical asymptote. So you need to be able to, without a graph, you need to be able to rationalize with reason, with previous knowledge, to be able to see what is going on. Okay, so if I think about this, the limit as x approaches -2 from the left. Okay, from the left. Well, some people have a hard time with this. Let me throw a number line here, -2. This is the left side of -2. So the left side of -2 would be a really small number, maybe like -2.001. That would be just to the left of it. Okay, this is a left-sided limit. To the plus side, it's the right side. Well, as I approach -2 from the right, that's like -1.999. That's my right side. We got to organize this. Negative numbers play wacky doodle with your mind. Okay, so we're going to evaluate this limit with some logic. Now, we're going to plug in. The numerator really doesn't matter because what's really going wrong here is we're getting a 0 in the denominator. We don't need to worry about the numerator. We can plug -2 in the numerator. Now, if I'm plugging a really small negative number in there, like maybe -2.001, if I add 1 to that, what I do get is I get -2 over -0.001. What am I talking about? I'm talking about something, I'm talking about -2 over a big number. This is going to equal big, okay? Something over small goes big because we know this is getting smaller and smaller and smaller. So the value of this fraction gets bigger and bigger and bigger. What do we have here? We have a negative over a negative, right? So that would be positive big. Well, don't use positive big anywhere in your AP test or in the test. We're thinking positive big is actually positive infinity. It's going to infinity. Now remember, that technically means this limit does not exist, but it tells me something about the graph, okay? It tells me as I'm looking at the graph, when I have a vertical asymptote here at -2, what it's x equals -2, what it is telling me, it's telling me as I'm approaching from the left, my graph is going to positive infinity. It's telling me which way my graph is crawling up that asymptote. Same thing for this next one, okay? The numerator, I can plug -2 in. Bottom down here, now is where I'm going with the small numbers, and I wouldn't, this is mental math for you, but I'm plugging in a very small number close to 2 here, and what I'm going to get is I'm going to get -2 over 0.001. Again, I'm running into Negative 2 over smaller and smaller and smaller because I'm getting closer and closer and closer to that. So what that gives me is that gives me a negative over a positive gives me negative big. Okay, so that's telling me as I'm coming in from the right, that's telling me I'm going down. Okay, so this is the analysis that we're looking through. Okay, this is a lens we're looking through. And when we go look at the graph, when we graph it in our grapher, after we do it, whoop, right side's going up, left side's going down. That is the analysis that we were talking about and that we are talking about today. So I'm going to hit here. Somebody just texted me, see if it's somebody for help. I'll be right back. All right, so we're back in action here again. We're going to do number 3 here. We're in the same directions. Find the vertical asymptotes of the graph of f of x and describe the behavior of f to the left and right of each vertical asymptote. Sometimes you can have more than one, obviously, okay? So by describing the behavior, we're asking, is it going up or is it going down? That's all we're asking. But then we are getting into the general knowledge of this all again, okay? You do need to be able to look at a function such as, such as this little guy. God, is that so stinking rotten annoying? We do need to be able to look at a function such as this, and you need to be able to pop off the cuff to me that you understand what the domain of this thing is, that the domain is all real numbers x except negative 1. Why am I saying that? Because negative 1 gets me the 0 denominator. And if I plug negative 1 in here, what do I get? I get negative 12 over 0, which a number over 0 tells me vertical asymptote at x equals negative 1. It's exactly what that tells me, okay? Horizontal asymptote. Well, horizontal asymptote, I can't overlook the obvious here now, okay? And because it is a rational function, we are definitely going to use, okay, the power thing. Okay, you only have to do all that dividing by the biggest power of the denominator if you're algebraically showing it. If we're just stating it, we can use the power thing. But please understand, to use the power thing, everything needs to be expanded. What do you mean by expanded? Well, I got to look at this thing, and I can see my largest in the numerator is going to be 3x. My largest in the denominator is going to be x squared because I got to square that out. The bottom is actually x squared plus 2x plus 1. And when it's big in the bottom, y equals 0 is the horizontal asymptote. Big in the bottom, y equals 0. Okay? So now what we're going to do is we're going to use this information to describe our asymptotes. What we're going to do is this vertical asymptote right here is going to help me. This leads me to limits to describe vertical asymptote behavior. Leads me to describe vertical. I guess I should spell it all. I should do it all. Leads me to describe, and I'm going to come underneath. Leads me to describe. Leads me to the limits to describe. To describe vertical asymptote behavior. Okay, I know there's a vertical asymptote. I know it's got 1. We're going to verify this in the graph when we're done. And when there's one vertical asymptote, if I'm describing that, what I'm doing is I'm coming down and I'm saying, okay, what the heck is the limit as x approaches that troublesome area that gives me the 0 denominator from the right side of 3 times 3 minus x. X minus 3, wow, I'm on fire here. Doesn't matter. Yeah, it does matter. X minus 3 over x plus 1 squared. Okay, now remember, this is the right side. And we also need to evaluate what is the limit as x approaches that troublesome area from the left side. of that exact same function. What is this going to do? This is basically algebraically showing if the graph is going up or down. Which side of the vertical asymptote am I going up? Am I going up on the left, up on the right, down on the left, down on the right, up on both sides? What am I doing? So when I evaluate these, okay, I basically, in the numerator is virtually just going to be a constant. So I'm always going to plug that target value just straight into the numerator, which is going to give me 3 times -4. That gives me -12 over. Now for the bottom, if I'm approaching, okay, if I'm approaching for the visual learners such as myself out there, when I'm approaching -1 from the right side, what small number am I plugging? Remember this number of -0.999, because I'm getting closer and closer and closer to -1. When I plug this in here, I have -0.999 plus 1 squared gives me -12 over, well, -0.9, well, that really gives me 0.001 squared. And you know, if you square 0.001, it actually gets a lot smaller. So a number over getting smaller and smaller, what's happening to that? It's getting bigger and bigger and bigger, isn't it? So it's going big, but is it going positive big or negative big? Well, this bottom, because I'm squaring it, is always going to be positive, so I really have a negative over a positive, so that means I'm going negative big, right? So that means when I'm looking at my graph here, with my vertical asymptote here at x equals -1, that's telling me, as I'm coming in from the right-hand side, that's telling me it's going down. That's exactly what that's telling me, okay? Now, from here, I'm going to start, I'm not going to plug all these numbers in, okay? If I'm approaching from the left side here, well, now I'm really -1.001, right? I'm getting smaller, closer on the other side. So if I plug this in, I'm still going to have -12 on the top. Now, if I plug -0.001 in, plus 1, I have -0.001 in there. So technically, it's -0.001, but I got to square it. Because I got to square it, this whole thing is going to be positive. So what I'm looking at when I write these out, I do all the denominator in my head, okay? And I'll plug that in. So I'll have -0.001 squared. That's positive small. And when I take -12 divided by positive small, okay, that gets really big because the bottom's getting smaller, 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 and it's still negative, which tells me when I look at this graph, the left side is also crawling down. Let's check it out if we did it right. So, boom, shakalaka, there, both sides are cruising down. There's my function. Beautimous, okay? So we're going to come here to the next page. And this next page, I'd just like you to try this one quick. Hit pause, give it a shot. Do exactly what we did on the one before, and then come back, okay? And I'm going to keep working it. So I do believe you should be able to know the domain is all real numbers x except 3. And because 3's not in there, 3's gives me a 0 in the denominator, so 3 is a potential candidate for a vertical asymptote. But when I put 3 in there, I get 9 minus 7, I get 2 over 0, number over 0, vertical asymptote at x equals 3. Okay? Also, now for my horizontal asymptote, big in the top. Ooh, what happened big in the top? We don't have horizontal asymptotes when it's big in the top because it's going to follow a linear end behavior, which means it's going to be going up, okay? So from there, this vertical asymptote statement leads us to say, okay, what is the limit as x approaches 3 from the right of x squared minus 7 over x minus 3? And as I'm approaching from the right, what does that do? When I put 3 in the top, I get 9 minus, I'm going to get 2 in the top. But when I'm approaching from the right, I'm really, right side, remember, so I'm really going 3.001, right? So this is over positive small when I put that in there, okay? That's going to give me positive big. That gives me positive big. So I'm going to come over here. I'm going to say 1, 2, 3. There's my vertical asymptote. And what that tells me is, as I'm approaching from the right side, okay, no matter what it looks like, I know in the end, I'm going to be crawling up that side of it. Okay. Well, let's investigate the other side. Well, what's the limit as x approaches 3 from the left, okay, of that same function? What does that equal? Now, when I'm to the left of -3, I'm really at 2.999, aren't I? So again, I'm plugging 3 into the top. I'm still getting 2 in the top. 2.999 minus 3 gives me basically negative small. And 2 divided by negative small is negative big. Which means as I approach it from the left, I'm going to be crawling down it somehow that way. And those are going to be my end behaviors. Okay? This is what you should be able to show me for your analysis right here. This is my vertical asymptote analysis. It's beautiful. And it tells, this analysis tells us that's what we should see in our graph. Do we see that asymptotic behavior like that in the graph? Look at there. Left side's going down, right side's going up at 3. Beauty-muss. Okay? And from here, summary on asymptotes. Okay, this is a general summary on asymptotes. And vertical asymptotes, well, they occur at values of x equals a, where that f of a value gives me a number over 0, like I showed before. And if I have that, then I can take the limit as I approach a from the right and the left to show whether I'm going up or down. Okay, beautiful. Horizontal asymptotes, this is the main ones we did yesterday. They occur at values of y equals c, where, because they're end behavior asymptotes, I want to get way out to the right or to the left and see if I'm getting snug as a bug in a rug to a specific value. Okay, that's what we're after. Those are my vertical and horizontal asymptotes. Okay, now we're going to skip number 5 in the note sheet because I'm going to do it tomorrow. And we're just going to go through this very little last thing, okay? Here is exactly, explicitly, what you need to be able to show me when we have our Chapter 2 test to find all asymptotes and verify those asymptotes using limits, meaning using calculus, because that's the class we're in, okay? We need to be able to take a snapshot, and this would be 100% non-calculator. We need to be able to look at this, and first and foremost, we're going to make it a little bit shorter so the video is not so long. Please add a +3 in your numerator. You'll see why it's going to be a +3 in the numerator. Change it. It's going to make our work shorter and faster. Okay? So you need to be able to look at this thing. You need to be able to read the denominator. You need to be able to say my domain is all real numbers x except -3 and 3. We need to be able to see that. We need to be able to find that. Once we find these troublesome areas that give me a 0 in the denominator, okay, then we will go through and we will dictate, is that a vertical asymptote or not? So what I'm going to do is I'm going to say f of -3. Well, when I plug -3 in there, I get 0 in the top and I get 0 in the bottom. This is not a vertical asymptote. This 0 over 0 implies a hole in the graph. It's not a vertical asymptote. Okay, I'm not going to be going straight up or straight down at f of -3. So then I'm going to check the other one, f of 3. Well, when I plug 3 in here, 3 plus 3 is 6 over 9 minus 9 is 0. This implies vertical asymptote at x equals 3. So I have a vertical asymptote at x equals 3. I just found that out. This is a key concept. Hole 0, 0, 0 over 0, vertical asymptote, any number over 0. Horizontal asymptotes, let's do the power thing. Let's do the power thing. Big in the bottom, big in the bottom. What is it when it's big in the bottom? You're right, big in the bottom is y equals 0. So we can algebraically calculate where these asymptotes are. And then what we're going to do is we're going to use calculus basically to do a small analysis to prove that we are correct. Well, vertical asymptotes, if this is my troublesome area, I'm going to look at the limit as x approaches 3 from the right, and I'm going to cheat. I'm going to say of f of x because I'm sick of writing the whole thing. And now remember, this is the right side because I'm above 3. If I'm above 3, I'm technically thinking of 3.001, okay? And when I evaluate this thing, I can plug the 3 in the top and get 6. I'm really plugging closer and closer to 3 into the bottom. Well, if I take 3.001 and I square it, I have a little bit more than 9, right? So if I have a little bit more than 9 and I subtract 9 from it, what I have is a positive small number. And if I have a positive small number, I'm going really big. And because it's a positive over a positive, it is positive big. Okay? So that tells me, that tells me when I'm looking at my graph, as I'm approaching this 1, 2, 3, that's going to be my vertical asymptote at 3. As I approach it from the right side, I'm going up. That's what it's telling me. That's my analysis. And for the left side now, I'm going to say what's the limit as x approaches 3 from the left of f of x. And you don't need to write these numbers underneath, but when I'm to the left of 3, I'm really 2.999. Right? 2.999? Woo! And I plug it in. And even when I plug it in, the numerator, like I said, it's constant. I can still see that as a 6. Okay? Doesn't really matter. Because 2.999 plus 3 is 5.999, which is basically 6. Okay? But if I plug 2.999 in there and I square 2.999, wouldn't that just be a little bit less than 9? Okay, 3 squared is 9, so 2.999's got to be just a hint less than 9. So if I take a number just a little bit smaller than 9 and I subtract 9 from it, don't I just get negative small? And when I take a number divided by small, it's big, and because it's a positive over a negative, it's negative big. That just tells me as I approach here, this side's going to be going down. Okay? That's what we did yesterday. That's what we did today. Horizontal asymptote, well, it's a whole power thing, Mr. Kruger. How do I show an analysis of that? It's super easy. You can use the concept of the power thing, but the calculus analysis tells me right here, when you take the limit as x approaches positive or negative infinity of f of x, when I take the infinite, when I get really big, positively and negatively, my limit is 0. Okay, this notation right there totally tells me that you understand how to find a horizontal asymptote. The limit as I go to infinity of a function is horizontal asymptote hunting. And that's what it is, and whatever it outputs is my horizontal asymptote. I hope today's video went a little bit better. It was a lot shorter, and hopefully tomorrow's will be even shorter. We will talk to you tomorrow. You should be able to do virtually all of the 2.2 homework if you want.